Hello friends, welcome to Shiksharthi. In this video, we'll be discussing how to make a quadratic expression as a perfect square, and at the same time, we will talk about the factorization process of a quadratic expression. So let's start. So as discussed in my earlier video, what we are going to do here is we will take a quadratic expression as ax square plus bx plus c. This is a quadratic expression, keeping in mind that a is a non-zero term. It's a non-zero number, right? Now, I would advise that, if you try and prove the theorems, it becomes easier for you to solve questions. So start proving. How do you come down to a conclusion as far as a formula is concerned? Try and prove it first, because in that case you are taking that theorem or a formula as a question, and henceforth it becomes easier for you to solve the questions, which is nothing but an application of the theorem, axiom or the formula that you would have done. Okay, so we are taking the basic form of a quadratic expression. Now if I take a common here, I can write this expression as x square plus b by ax plus c by a. Further to this, now we have to make this a perfect square. Now when you are making it as a perfect square in a certain way, you are doing what? You are writing it in the form of ax square, which we talked about in the very first video, various forms of quadratic expression. So now what is ax square? Ax square is nothing but a times of x into x. So when you are making it as a perfect square, actually you are discussing factorization only, which is a multiplicand into a multiplier. So we need to convert this into something like, please understand it like this, you're trying to convert this into a times of x square. This is the point that you need to understand from here, and let's see how we are able to do this. So now when you are making this as a perfect square, you know what is the formula for a square when you write? We write that, let us say if I have to write it as x plus b by a whole square. Now why have I written it like this? Because I have a b by a here, but when I expand this and I see x squared, then the next term is twice of x into b by a, I get 2b x by a, but I am supposed to get only b by ax. So make this as b by 2a. So in that case we are saying what? We are saying x square plus bx by a. So you get the first two terms, followed by what additional terms do you get after this? You will get the square of this, which is just like saying b by 2a whole square. And then you are supposed to get this term as well. So you know how to make this as a perfect square now. Okay, so let's see how can I make this. So what is the value? So what is the value of x square plus bx by a? X square plus bx by a is this minus this. So can I write this as x plus b by 2a whole square minus b by 2a whole square from here? And then, so this gives me what? This gives me simply x square plus b by a, bx by a, and then I need to have this term as well, which is c by a. Okay, going further, can I write this as a times of x plus b by 2a whole square, right? And then I take minus sign as common, and then somehow make this also as, so I know that this is the denominator here is what? 4a square. Can I write this as 4a square? So I'm multiplying the numerator and the denominator by 4a. So in that case this becomes 4ac. I repeat, now this denominator here has to be made as a 4a square, because here I will take that thing as common. So what I have done here is, I have multiplied the numerator and the denominator by 4a. In that case, c by a can be written as 4ac upon 4a square. So now when I have taken minus as common, I can write this as b square minus 4ac. Correct? The next step which I can write after this is a times of x plus b by 2a whole square minus, and I want to make this as a perfect square. Why do I want to make this as a perfect square? Because I want to write it as a times of x into x, and I know that I know the formula. Which formula am I referring to? A square minus b square can be written as a minus b into a plus b, which is just like writing a number as a product of two numbers, right? So incidentally, in this case, it is just like understanding as x into x, wherein it will not be exactly x into x, but we'll see. So here, can I say this can be written as under root of b square minus 4ac divided by 2a and the whole square of this? So when you take the whole square, so when you're taking the square of the under root, you get b square minus 4ac, and when you take the square of 2a, you get 4a square. Now for further discussions, what we'll do here is, for further discussions, let me say that I am putting the value of b square minus 4ac as delta. I am assigning a value to this. There is no need, I could have taken some other thing also, but as there is a norm, I mean, if I talk about Brahmagupta or Sridhar Acharya, they had given some name to this, and maybe there are others also, those who gave a name. We can't change the nomenclature. So we are taking this as delta. Now delta is known as the discriminant. Certain books represent it as capital D also. It doesn't make any difference as long as you know that this is a discriminant. Okay. So now after this, finally, can I write it like this is a times of x plus b by 2a whole square minus root of delta by 2a whole square. And then using this formula, this can be written like, using this can be written like a times of, so x plus b by 2a. So once you will subtract this, which is minus delta upon 2a, and the next you would add this x plus b by 2a, and you would add delta by 2a to this. Now this proving is really important, because when you are proving this, you are learning so many things. Please understand it like this. This is what I was telling you. Okay. So now further to this, can I say that this can be written as a times of, and we are converting this into now basically what? A times of x minus alpha into x minus beta. So this is how we started, but the basic objective is to convert this into a times of x minus alpha into x minus beta. This is the basic objective. Because I know when I am doing a minus b into a plus b, both of them cannot be written as x into x. So this quadratic expression is being converted into an expression of a times of one linear expression into another linear expression, because we are trying to factorize, we are trying to square it up. Okay. So now if I am taking x minus, if I take minus as common here, so let us say I take this first. So in that case, can I write this is nothing but minus b minus root delta upon 2a? And then I multiply this with x minus, when I take this as minus as common, then minus b plus root delta upon 2a. So now finally I can say that this has to be understood as, so equal to, so can I say finally this is nothing but saying like a times of x minus alpha into x minus beta, wherein this value inside the parenthesis, inside the bracket, is the value of alpha, and this value is inside the parenthesis is the value of beta. So now x minus alpha and x minus beta are the factors of this quadratic expression, right? And the moment I equate this expression to a 0 or any other constant term, so let us say I say ax square plus bx plus c is equal to a 0. The moment I say this, that means this becomes a quadratic equation. So when does a quadratic expression become an equation? It becomes an equation only when it is equated to something. So maybe a quadratic expression is equated to another quadratic expression using the same variable, or a quadratic expression is equated to a linear equation, or a quadratic expression is equated to a constant term. In all these three cases, so maybe I can write it down for you. So the first case here is a quadratic equation, let's say expression. If a quadratic expression is equated to another quadratic expression, or a quadratic expression is equated to a linear expression where Lx is my linear expression, or third, when a quadratic expression is equated to a constant term. In all these three cases, you can say that this is a quadratic equation of that particular form. But now what I am saying here is, let us say if this quadratic equation is equated to a 0, the moment you equate it to a 0, it is then only you talk about the zeros of a quadratic equation. So if you do not equate it to a 0, in that case you have to adjust and then finally equate it to a 0 so that you can find out the zeros of the quadratic expression or the equation. Right? So if you feel that this video was very knowledgeable and informative, and this can help you immensely when you start solving the questions, which also we will be discussing in our other videos, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on specific topics or difficult topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.